So this one is part 3 of your quarter 1 study guide. We are solving equations now, and I said distributive and like terms. So when I see this equation over here, I see two sets of parentheses, so I know I'm going to have to distribute out those numbers out. So we need to multiply by the outside numbers. So I'm going to use this line just to help me organize my work. You don't have to put it. And then I'm going to distribute out the 7 to the x and the 3. So 7 times x is 7x. Pull down your plus. And 7 times 3 is 21. Now for the second one, you got to remember that's not just a 2 sitting out there. This subtraction sign goes along with that 2. So that's really a negative 2. So I've got to say negative 2 times x is still negative 2x. I know it doesn't look like anything changed there, but right here's where it changes. Negative 2 to a negative 8. So negative 2 to negative 8 makes positive 16. Alright, that equals 17. We're going to go down to the next step. So for this step, we need to find our like terms. Let me get a different color here. Like terms, we have really two of them. We've got ones with variables, like these two. And we're going to say 7x minus 2x is 5x. You could also think of that as 7x plus negative 2x. Our other term is called a constant. That means it doesn't have variables. So like this positive 21 and this positive 16. So when I add those together, I get positive 37. And that equals the 17 that I'm pulling down over there. So for my next step, I've actually got a good old two-step equation. I need to get this x by itself, so I need to subtract off this constant. So I'm going to get rid of the 37 with a negative 37. It's gone. I've got 5x then is equal to 17 minus 37 is negative 20. One last step. This is 5 times x, so cancel that one with division. So there we go. We've got x is equal to a negative over a positive is a negative, and that gives us 4. 20 divided by 5. You can check that out and make sure it's right by plugging it back in. So if I go back into my equation right here and I say 7 parentheses, instead of the x, I'm going to put what x is equal to, negative 4 plus 3 minus 2 parentheses again, and I've got x minus 8, so I'm going to say negative 4 minus 8. I'm actually going to solve this now with PEMDAS and see if it does equal to 17 like it says it should be. So PEMDAS says parentheses first, so that's negative 1. And I've got to say 7 times that, so that's negative 7. Over here, I've got negative 12 times a negative 2, so that's going to make positive 24. And negative 7 plus 24 is indeed positive 17, so we know that's correct. So take a moment, pause the video, try this one all on your own, and then come back and see the explanation if you struggle at all. So for this one, I'm going to go ahead and start with the distributive. This 6 is just a 6 that needs to be included later in your like terms. This is really a negative 1 on the outside, and I need to distribute negative 1 through this parentheses. I put that problem on here specifically because I see that issue come up a lot with many of you. So I've got negative 1 times 2x, which is negative 2x. Again, doesn't look like anything changed yet, but right here's where the change happens. Negative 1 times positive 4 is negative 4. Now I get to distribute this positive 3, so let's go and do that. That's 3x. So it was positive 3x, so I put the plus there. And 3 times 7 is positive 21. Alright, this little bar is just for organization. Now I need to go and do my like terms. So I'm going to grab a different color to do this. I see two different types. I always like to start with my x's, so make sure you get those signs in front of them as well. So if I have negative 2x and positive 3x, that's just one x left over. Then I also have this 6, this negative 4, and this 21. So 6 plus a negative 4 is 2, plus 21 is 23. I'm going to bring down what I haven't used yet, the 21. Now you've got a good old two-step equation, so we need to solve for this 1x. So I'm going to subtract my 23 to the other side. That gives me a 1x is equal to negative 2. I can stop there because we know by our identity property that this 1x is the same as x, or you could just divide by your 1 and you'd still get the same answer. So x is equal to negative 2.